The engineer who deleted GitLab's production database. On January 31st, 2017, an engineer typed a command into a server. A few seconds later, he realized something was wrong. He was connected to the wrong machine. Instead of deleting data from a secondary database server, he had started deleting GitLab's primary production database. By the time he stopped the command, almost everything was already gone. This is the story of how one of the world's largest software platforms lost production data, why most of its backups failed, and why the engineer responsible was not fired. GitLab is a platform used by developers to store code, manage projects, track bugs, and collaborate with teams. For many companies, it is a central part of their development process. Projects, comments, user accounts, issues, merge requests, and other important information all depend on its infrastructure.
And on that night, the infrastructure was already under pressure. GitLab's database was experiencing unusually high load. Part of the problem came from spam activity. The primary database was receiving more work than usual, while the secondary database began falling behind. The secondary server was supposed to copy changes from the primary, but the delay became so large that replication eventually stopped working. The engineers now had to rebuild the secondary database. The process should have been relatively straightforward. Clear the old database files on the secondary server, create a fresh copy from the primary server, restart replication. But the repair did not go as expected. The copying tool appeared to freeze. It produced almost no useful information. The team tried again. They changed database settings. They restarted services. Hours passed. The engineer working on the problem had already planned to stop for the night.
But the situation kept becoming more complicated. He was tired. The system was unstable. The pressure was increasing. At some point, he believed that the copying process might be failing because the database directory still existed. So he decided to remove it. The command itself was not unusual. The problem was the server. He thought he was connected to the secondary database. He was actually connected to the primary production database, the database used by the real GitLab.com service. The command began deleting the data. After 1 or 2 seconds, the engineer noticed the mistake. He stopped it immediately. But computers can delete information extremely quickly. The database had contained roughly 300 gigabytes of data. When the command stopped, only a small part remained. GitLab had just lost its primary production database. At this point, the obvious solution was to restore everything from a backup. That is what backups are supposed to be for. But this is where the incident became much worse.
Several backup systems existed. Some were too old. Some were not designed for disaster recovery. And one of the regular backup processes had been failing silently. The system was producing backup files that were almost empty. Notifications about those failures were supposed to be sent by email, but the emails were being rejected. So the company had backups, but many of them could not actually save the company when they were needed. There was one useful copy available. Earlier that day, an engineer had manually created a snapshot of the production database for testing. It was around 6 hours old. That snapshot became GitLab's best chance of recovery. The company began restoring the database from it. But the snapshot was stored on slow infrastructure. Copying the data took many hours. GitLab.com remained unavailable while engineers worked to rebuild the service. Instead of hiding the disaster, the company made an unusual decision. It documented the recovery process publicly. Updates were shared with users. The recovery was even streamed online, allowing thousands of people to watch the engineers work through the problem in real time. Eventually, GitLab.com returned. The code repositories and wikis were stored separately, so they were not deleted. But several hours of database activity could not be recovered. Thousands of projects and comments were affected. Hundreds of newly created user accounts were lost. The incident was serious.
But the most interesting part of the story happened afterward. The engineer who entered the command was not fired. GitLab did not present the outage as the failure of one careless person. The company examined the entire system around him. Why was it so easy to confuse the primary server with the secondary? Why was the recovery process not properly automated? Why were the instructions incomplete? Why had the backups not been tested regularly? Why could a failed backup process remain unnoticed? Why did one exhausted engineer have to perform dangerous manual work late at night? The command caused the deletion, but the organization created the conditions that allowed one command to become a disaster. GitLab later explained that the engineer was experienced and highly capable. The incident did not cancel a promotion that had already been planned for him. That decision sent an important message. Serious engineering failures are rarely caused by one person alone. They are usually the result of several weaknesses lining up at the same time. Unclear infrastructure, incomplete documentation, broken alerts, untested backups, manual procedures, fatigue, time pressure. Each problem may look manageable on its own. Together, they create the conditions for failure. The GitLab incident teaches one of the most important lessons in technology.
A backup does not exist just because a system says it created one. A backup only exists when someone has tested that it can be restored. A recovery plan is not useful just because it is written down. It is useful only when people can follow it safely under pressure. And a production system is not reliable just because talented engineers operate it. Even excellent engineers make mistakes. The system must be designed with that reality in mind. Because the goal of good engineering is not to create a world where nobody ever makes a mistake. That world does not exist. The goal is to create systems where one mistake cannot destroy everything. One server, one command, a few seconds, and nearly an entire production database disappeared. But the real failure was much larger than the command itself. It was every missing protection that allowed the command to matter.